In this presentation, we will take a look at a loan amortization schedule because that will allow us to break out the interest and principal portion of a loan and make the payments accordingly. For more accounting information and accounting courses, visit our website at accountinginstruction.info. In order to do our more complex option of breaking out the interest and principal portion, we need to know of which payment, for each payment, how much is going to be a principal portion and interest portion. To do that, we need an amortization schedule. Now, the amortization schedule is something that our loan often doesn't give us. The bank office doesn't give us, or if we finance equipment, or if we get a car and we finance it, you probably notice you don't typically get an amortization schedule. If you look at the financing, we typically do get the loan amount, the amount of payments that we're going to have, hopefully the interest rate, although they could leave out one of these items and we can just figure it out, so they might leave out the interest rate and we'd have to figure it out, and then the payment amount. So they'll give the payment amount here. Based on that information, then we can figure out how much is going to be interest and principal. Now, we can figure out for the entire time period how much is interest and principal, because we can think, well, if the sticker price, say if I bought a car was $50,000, or if I got a loan today for $50,000, and I'm going to pay $944 each month for times 60 months, that would be 56,640 minus 50,000. That means I have 6,640 of interest. If I divide that by 60 payments, you would think you'd be paying 110 each time, but that's not exactly right, because the interest actually changes each time, and we'll see why in a second here. So we have to then, every time we make a payment, then the amount of interest will change. So let's see that in terms of a table. And again, I'm going to make this table. This might be something that we either have the accountant help us to make, and then we just use the table to break out the interest and principal portion. But it's useful to at least know why this has happened, why this is a problem. Okay, so we're going to go through this amortization table, and we've got the number of payments up top. And so there's going to be 60 payments. If we scroll down, we'll have 60 payments. And then we're going to have the payment amount, which is going to be this $944. We'll break out the interest and the reduction in principal. Do that all the time. So I'm going to start off with the loan balance. The loan balance is going to be at times 0, 50,000. The payments are always going to be equal to, and I'm doing a little bit of Excel here, so equal to the 944. You could do this by hand too, but Excel would be much easier. Okay, and then we're going to calculate the interest. Now the interest for 1 month then would be the 50,000 times the 5%, 0.05, but that would be for an entire year of interest, because every time we say interest, it really means for a year time period. That's what interest means. That would be like if I was just saying the rent is, like if we were renting a place and we just said the rent is 2,000, we just assume it's 2,000 a month. They might not even say a month. We kind of assume that. When we say interest, we mean a year, really. So really we're paying, this means for a year, and we're paying it monthly. So we're going to take that and divide it by 12, and that would be the interest per month. And the reason you do that, note, because if I took this interest rate, which is 0.05, if I move the decimal point over, and divide it by 12 months in a year, we would then get, this would be the monthly rate, and it's way small, or it's a really small number. So that's why we don't really talk about interest rates in monthly terms, because it would be very small. But if we did that, we multiply that times the 50,000, we should get the same thing. So let's do that here. With a formula, I'm going to say this equals this 50,000 times the 5%. I'm just pointing to it, so a formula is going to be like this, equals, and then that means it's going to have a formula. We'll point to that 50,000, which is in cell E8, so E8 times this 5%, which is in cell B3, so E8 times B3. Then I'm going to take that and divide by 12. Just hard-coded number because it's 12 months. So there's the 208 rounded. So if this is how much we're paying and this is how much is interest, then the principal portion would be the payment minus the interest, or 735. So then this principal amount, the ending principal, will be equal to the prior principal minus the 735. So you would think it would be the same all the way down. You'd say, oh, well, every time we make a payment, then interest would go to 208 interest and the difference would be 735. But no, because it's going to change, because now the principal portion actually went down, and interest is really a result of paying kind of like rent on the purchasing power. So we don't have 50,000 anymore. We only got principal portion of 49,265. So the rent on that portion in the second month, the interest payment on it, is going to be slightly lower. So the reason this is a problem is because we always want to keep this the same, the payment the same, because we don't want to confuse people on what the payment is. So we don't change the payment amount because we want people to just be able to make the same payment. But the interest is going to change each time because the principal amount has changed. So that means that this combination between interest and principal will differ every time we make a payment. And the reason we do that is because we don't want to make the payment differ every time, because that confuses the person making the payment. So this is the confusing part that we don't really see. It makes it a little bit more difficult here, but that's how we do it. So we're going to say now the interest is going to be equal to, let's do this in a calculator first. It's going to be equal to 49265 times 0.05. That would be interest for a year divided by 12. So it's a little bit lower now in interest. So if we do that in Excel, put my cursor here, equals 49,265 times the 0.05 or 5% divided by 12. And there's the 205. So if we subtract this out, then here's the payment minus the interest. There's the principal reduction. And now the new principal is going to be equal to 49,265 minus the 738. And so you can see it's slightly different, and this will vary more depending on the interest rate. So, and it'll keep going as we go down. Let's do one more, and then we'll try to copy this down. So the payment will always be the same, equals that number. Interest is going to equal the new principal times 5% divided by 12. And then the principal reduction is going to be equal to the 944 minus the 202. Then the new principal is going to be equal to the prior principal minus the 741. Now we don't have to do this all the way down because Excel will help us do that. So what we'll do is we'll just highlight or select from this cell B11 to this cell E11. So from B11 to E11. And then we use this little item. It's going to be called an autofill type item. So if you put your cursor here so it doesn't look like that, but like that. Not like that, but like that. Right on that corner. And then you left click and drag it down. That'll try to predict. Excel will try to predict what we want to happen. Now it doesn't predict perfectly now. If we see why, we say this one does what it wanted because it just said equal the prior one. That looks good. This one looks messed up, and that if we widen the cell, we can see, okay, that doesn't look right. I widen the cell by putting my cursor right between these two cells and left clicking and widening when it looks like that. And so if I double click on this, I can see, okay, it moved this cell down, and I want to keep this 5%. So what I'm going to do is I'm going to undo all this. I'm going to hit enter and then undo. I'm back up here, and I'm just going to try to tell Excel, hey, I don't want you to move. I'm double clicking on this cell. I'm going to tell Excel, I don't want you to move this 5% down. I want you to move this cell down, but not that 5%. So the way to do that, that 5% is in cell B3. So we'll put our cursor here in B3. I'm going to select F4 on the keyboard. You can also just put a $sign before the B and a $sign before the 3. That's called an absolute reference. So if we do that, we could use a mixed reference, but I'm just going to use an absolute reference. And that's just code for QuickBooks. These $signs don't have anything to do with money. That's just code telling QuickBooks, hey, put a $sign or don't move that cell. So then we say enter, and then we can select these cells again. And now let's autofill down just one cell and see if it does what we would expect. So that looks good. That looks good. So it looks good now. So now we can just select these cells again and autofill all the way down. So we'll put our cursor on this autofill icon, this square, left click, and go all the way down this time, down to 60. Now once we do that, this cell should then be 0. So it goes to 0 at the end of 60 payments. That would be the indication that we have done this correctly. You can see that this last payment, we're still going to pay $944, like every payment, but only $4 of it is interest, and $940 is principal to bring us down to 0, as opposed to this first payment, where we still make $944 payment, but $208 of it is interest, and $735 is principal. So when we record these transactions, then every time we make a payment, it's only going to be for $944. But if we do this in a more complex or the completely proper way, we can't just put that $944 to one account, such as the loan payable. We have to break out interest and principal, and not only that, we have to change the amount that's going to interest and principal each time. That's our challenge, and that's what we need to think about how we want to do that. Do we want to do that with each payment in accordance with an amortization table such as this, or do we want to do that by doing an adjusting entry at the end of the time period, meaning giving the documentation to an accountant at the end of the year to make this amortization table and break out the interest portion at that time, at the end of the year, at the end of the month or year. For more accounting information and accounting courses, visit our website at accountinginstruction.info.